I can hear you, Michael.
Yeah. Okay.
Yeah.
Okay. So effectively, you know, apart from what the energy champions are already doing, is with terms of energy advice at the property and looking at price comparisons and things like that, taking up to the next level, there is more about sort of evaluating with a client on site as to what their wishes are, what their priorities, and what they're looking to do. So these can come in various forms. We come through various organisations that we work with. For example, East Sussex County Council are currently running two sort of types of measures. One is called the Warm Home Check, which really is where we would go along. We would look at the property as a whole and effectively produce a draft EPC for that property, which will identify areas that could be improved, some of which may not be able to be done under the schemes, but other areas may be. I'll just go through those schemes a little bit later on, but primarily with these side of things there, it's more helping the client out in the initial things. It could be because we've gone there because the boiler's broken down, they can't afford to repair it. It may be beyond economic repair or been condemned. So we do look at various organisations that may be able to help. And as I say, the first one is the Warm Home Check side of things. So they would look at maybe increasing loft insulation, topping up cavity walls if there's no insulation in there. The basic things like RAD4s behind the back of radiators, increasing further insulation to the hot water cylinder, changing of light bulbs, and the sort of basic things like that. Minor measures would come under boiler servicing, boiler repair. In certain areas like Hastings and St Leonard's, for example, there are some local, what we call the DFG grants, which is a Disabilities Facilities Grants. Most councils have these, but use them in different purposes. So that could be for, if somebody in Hastings and St Leonard's, if they meet the criteria under the scheme, they could get their boiler replaced completely free of charge. Now, it could be like an Eastbourne, they use their disabilities and facilities grants more for changing of, say, bathrooms into wet rooms, where seats are available for those that may be disabled and unable to get, or elderly that can't get into baths and things like that. We're then overviewing with them their energy costs and to see comparisons of how we can improve that. Obviously, the way things are at this moment in time, it's not really anything we can do, and I'm not quite sure when we'll be able to get back into that, and I don't envisage much of that happening until towards the end of the year. So once those areas that we are able to identify can be done, it could be they may not have any thermostatic radiator valves, for example, on their radiators. So again, those are sort of things and sort of reasonable minor measures that could get installed under that type of scheme. The next level is the LAD, which is the Local Authority Distribution Schemes. And with a lot of that, it starting to look more into the whole house and what we call a whole house plan. So when we go along there, we're identifying, you are primarily becoming a little bit of a surveyor at the time, in the sense you're identifying issues with the property as a whole. Firstly, looking at the external envelope of the property, what's the pointing like? Are the tiles missing? So is there anything there that needs to be addressed before any of the insulation measures that could be recommended, etc., need to be done? Now, under the LAD scheme, there is currently under LAD 1B, which finishes at the end of this month and is hotly pursued by LAD 3, where clients can get up to £10,000 worth of work free. Now, this could involve things like solar panels going on the roof. It could involve internal wall insulation, suspended timber floor insulation, and so forth. There is a raft of measures that could get carried out. It is limited at this present time to 10,000. There is talk of under LAD 3 scheme, that's going to be a bit more weighted. So where rural properties are on, say, LPG or oil, or using electric on old storage heaters and things like that, that they may get increased funding to able to put in things like renewable technologies of air source heat pumps, etc. So the real idea is that the assessor is really looking at what could be done, listening to the client's wish list. Now, some of them, because they may be on low income and poverty poor in the sense of fuel and things like that, that it comes to really more people sort of identifying their concerns at that present time, which normally is about generally their energy bills, how high they cost, they're very drafty, the windows leak, and so forth. And from there, we identify within the program what areas could get carried out. You obviously will have some people as well that are able to afford to do some of these measures and may not meet the criteria. So we start to look at the modeling of these measures going forward in terms of phasing. So we're always looking at fabric first approach. So we're trying to sort out all the areas from, is there sufficient loft insulation? Do we need to do external wall insulation, cavity wall insulation? So initially, when we do a whole house plan and we do that, we listen to what the client's priorities are. And then obviously subject to their budgeting and things like that, when we do the whole house plan, we will give an indication of expected costs for the measures. We'll identify all the measures that could be done. And then after the clients had a chance to review that information, we can then start to remodel it. We can say, look, this is the key things we would like to do. So initially we want to get our cavity walls insulated. We want to increase loft insulation, and we want to change our windows. So what we would then do is remodel the whole house plan. And what I'll do now, if I may, I'm just going to share my screen. Hopefully it'll work. Can you all see that?
No.
No? Okay. Why is that then?
Give it a minute or two, Michael, because when we practiced, it took a few seconds.
I'm just trying to see. It was working perfectly earlier, wasn't it?
It was, wasn't it?
Let me go back to, let me try and pick it up this way.
Oh, there we are. It's come up.
Yeah, okay. So really this is now what we're starting to look at a whole house plan for an example. It gives you some introduction to that and the methodology and what we're primarily trying to do. Here are a list of the priorities that the client was looking at to have solar thermal, to thermally upgrade the suspended timber floors, to increase loft insulation, etc. Basically underneath there, you've got a bit of the model assumptions. And this is what the property is. It's a 2-story semi-detached house, room in roof, built around the 1930s, etc. And it will give a list of that. What you've got a little bit of bump for looking about sort of government strategies and how we'll be able to help. What we start getting into is within the software, it will start to model saying, right, based on the information that's been put in there, we've got a confidence level of the data is 9.8. So that means that somebody has been to site, gathered the information and inputted that into the software. It's giving you what the EPC rating would be currently, what the annual fuel bill is, and then you've got your carbon tonnage, etc. Compared, this is what expecting your property is using, and this is what they reckon the average UK home is meant to produce in there. So again, you've got lots of information as to the breakdowns of where the energy in terms of kilowatt hours is being assumed to be used from the renewables, lights, hot water, etc. Here we then give a potential of about the energy use and retrofit. Now, some of these don't look like they've changed at all, primarily because they haven't been recommended within the system. So they're just showing the general areas that could be carried out. So in red is what the current property's usage is under kilowatt hours per year in terms of energy. And in yellow, with the works that get carried out, it's more than what the savings would be. And you start to look at the reductions in fuel bills and things like that. Now, you can see here that it's not making a terrific amount of difference, but a lot of this modelling here is to do through the LAD scheme, and it is primarily geared up for just the replacement of thermal doors and things there. What it will then do is it will go down into where you are now, and ideally to get to zero, you know, you may need, as the improvements go along, that will reduce. But even if you did everything that you possibly could do to the property in terms of retrofitting, you may still have a shortfall, and then it will start to sort of say how you can offset that, whether that's by planting trees, whether that be in your property or elsewhere. But it would tell you how you get from there. Within the phasings of the improvements, when we initially do these, we do everything that could go into or wants to be done at the property. We would then discuss with the client at this point what they would like to happen first, and it would be phased. Then this could be done over a period of time. So it could be 2 or 3 years. But the key area of the phasing is to do things that you're not undoing works that you're already creating or have had carried out. So, for example, if you were looking at putting solar panels on the roof, but battery storage is too expensive at this present time, you would, or even if if you couldn't afford to put the solar panels on the roof yourselves, then just put the cabling in place, because you're doing you might have had to be adding an extension on and things like that. You've redecorated the whole house, but as you come back to start to put these measures in later on, for the sake of £50 worth of cabling that's already been placed in the wall, you're spending hundreds of pounds making good, sort of any of the works that's just recently been finished. So again, it gives you a technical review of what, with regards to the loft installation, the solar thermal indoors in this instance. It will start to talk about, the sort of areas of grant fundings and things like that later on. What we do have, which is more importantly, this is a sort of list of the options or measures that could be carried out at properties. I've left these ones in fully, but you can see it virtually covers everything that could possibly happen at a house. We do have further measures that we could add in as well. The list isn't exhaustive, it's just too long. It comes to around about 7 or 8 pages. When we model these, we will start to model and highlight specifically each measure. But that aside, as you can see here, it will give you different options of solar panels on different roofs, different pitching, different shading and things like that. It'll give you the costs. It'll tell you to tell you what your improvements would be on your scores, the estimated savings, and basically the cost per point of your SAP change. So if you increase your efficiency of your property, to do that, it's cost you £639 initially. But over time, as these things do, you're getting further monies back. Your fuel bill savings will start to go down, as you can see here, from £790 to £370, it's estimated. It's saying at that rate, it's 17 years to pay back. The reality of what we're finding is these are just computer generated at this present time. If you're utilizing the energy more and more, because you may be all electric, for example, because some of these will still take the option that your heating may be things. So we can remodel these to show what heating system is going to be in. This one is based on the fact that it's got gas electricity, But if an air source heat pump or a ground source heat pump was installed, the payback would be a lot quicker because you're utilizing virtually all the energy. It also assumes like it's 50% will go back to the grid. But again, the more you use of the better it is. And then you've got your kilograms in savings there. So that's primarily your sort of whole house plan. But these things, once you've done the initial one, it can then be designed more bespoke to the client's wishes and things there. So it's this one here is catering more for people that are getting monies through various grant schemes, like the LAD scheme under the East Sussex Councils and things like that. So really, it's more about also we speaking with clients on site about their occupancy use and how they use their energy. Do they understand their heating controls fully? Do they know how to maybe bleed a radiator and have confidence in doing that? So these are sort of things that can be shown, and people can come around and go through, like a certified installer will come and show them how their system should be fully functioning, not just keep turning down the dial, turning it up to the temperature they want, and when they don't want it on, they turn it to 0. So again, if they can start to program their use and things like that. With regards to how do you go about if you're interested in about doing these sort of things?
Michael, you've gone quiet for some reason.
Right? What have I touched?
But just I'm not. But just to let you know that you've got 2 minutes, and then we're
okay. So with regards, there are lots of training things to be able to get onto this, but more importantly, as I say, I think if anybody really is interested, I'm more than happy to speak to you on a one-to-one basis. If anybody wants to know what the process and the pathway is to help to be able to do these sorts of things, I can certainly help there. And again, about where to find grants and funding availability for anybody that you may not be able to help yourself, but you feel that they need somebody else to go along. Okay.
Thank you very much, Michael. We've got lots of questions that have come up in the chat box.
Okay.
And we will bring them up at the end. We'll invite people to ask them at the end.
No problem.
But if you want to respond to any of them while Nikki gives her presentation.
Yeah, I will start to do that.
Feel free to do so. I'm handing over to Nikki Myers now at Avesco, who has been running a community heat project. Anyway, Nikki will tell you about that.
Hello everybody. Right, okay, so hopefully you can all see my presentation. If you can't, I'm sure somebody will say. So I am today going to quickly run over the project that we've been working on in Barkham, and then explain to you the surveys that we've been doing there, and give you a couple of kind of overall results from the project so far, and then also just quickly show you a particular house that we surveyed and the kind of information that we got from it. So my name's Nikki Myers. I work for Avesco, and I work on the Community Heat project, which is based in Barkham. Oh gosh, hang on a second. Oh, right, okay. So what is Community Heat? Community Heat is a project which is looking into a planned approach, a whole system planned approach to a community which is on oil heating, and what is the optimum way for that village to transition to electric heating, to come off fossil fuels, because we know that fossil fuel based heating accounts for about 1/3 of UK carbon emissions. Heating oil has a higher carbon than gas central heating. And Avesco is involved in this project because we are all about community-owned energy, because we think this gives local ownership, resilience and leadership. And boy, has the last few weeks shown that we need local resilience. The project is we're working with UK Power Networks because they need to upgrade their grid for the future, the coming future, and Borough Happold, who are an international engineering company who work in this area. They work in local area planning, local area energy planning, and they've been the centre of the information processing. And I'll say a bit more about that later. So community, the first part of it, we reached out into the community, which was very interesting because it was in the first part of the pandemic. So we had to look at different ideas of how to do that. And we then gathered information, which we then sent back to Borough Happold. And they mapped a simulation of the village. And I'll talk a little bit about that later. We wanted in the project to understand the impacts, not only on the community, but also for UKPN and anybody else as well, of a planned or unplanned approach to the grid in this transition. Sorry, I'm just checking. I've had a message actually from UK Power Networks saying that I might lose my power to my house. So if I go dead, that's why, and apologies, and I'll hand back to Liz. So we have basically been talking with the village and discussing with the village how this transition impacts them and to choose the best path to zero carbon. So part of the work that we did for this project, we identified local energy champions in the village because we wanted to survey some of the houses to really understand the energy use. So we asked them to be trained up by an experienced EPC surveyor from Forest Row Energy, and there he is, that's Frank, surveying a house with a mask on, so you can tell it's in the last 2 years. Our local energy champions were trained to survey 150 households, and also almost 50 of these houses had non-invasive energy monitoring equipment installed. And we did all of this over the winter of 2021-22. And as a thank you to these households, because it was slightly intrusive, we offered them a local voucher to say thank you, because we're all about local. So here's some of the detail of what we did. So we targeted we didn't end up doing, but we targeted 100 houses for a room by room heat loss survey and 100 houses for whole house heat loss survey. And we used Heat Engineer software, which is up to a CIBSE standard. So it's not SAP. And it's also MCS standard. And MCS is a standard for calculating for heat pumps, for sizing heat pumps. And basically it calculates the U value of each thermal surface in your house. So you have to identify how each house, internal and external, is made, whether say it's cavity wall and how big the cavity is, whether it's a solid wall, whether it's perhaps timber, whether the internal wall is solid or and how big it is, because all this will determine how much heat is lost from the house, and also the roofs and also the floor. We'll also have to identify the windows, are they double glazed? And the software also asks that you size the radiators. You have to measure up all the radiators because we're interested in how much those radiators emit heat out to see whether they're suitable for heat pumps. And for those who might not be quite so technical, a U value is the measurement we use for the thermal resistance of a material, of the layers that make up a building. And how effective the elements of the building are to keep in heat. And the lower the U value, the better, because it's more resistant to heat loss. I'm not going to go into it in any more detail than that. There will be a lot to read up about U values if you want to, if you look online. So I've been through all of this, each of the thermal surfaces, and also the radiators, the emitters. So emitters can also be underfloor heating, or you can also have air heating as well, blown air heating, or grills under the floor. So there's slightly different types of emitters. So we did a room by room survey, but we also did a whole house survey, which was much quicker because we just measured the external elements of the house and not the internal elements. And we also fitted monitoring devices to record the heat used in the house and also the electricity used in the house. And heat is an interesting one for off-gas grid houses, because you can't really take information from bills, because you have 1,000 litres of oil delivered and you don't know how much you use. Whereas at least on gas you can look at your bills. So we fitted data loggers, and the one that's in the picture there, they're called RC4 data loggers, and we fitted them to the heating pipes, domestic hot water pipes, and also a logger in the living room to see the temperature of the room. This was, quite frankly, really difficult. We fell back on a technical person, Jamie, who we couldn't have done it without him, to be honest. The equipment didn't work very well. Certainly houses which are off gas are just not houses which are a textbook or behave in a theoretical manner. They, sometimes they're old, their heating systems have developed over time, and it's quite difficult to identify the pipes that you need. Cupboards are full, full of, airing cupboards are full of sheets and stuff. So it was a really difficult exercise for us to do. The electricity Eco-Eye equipment we installed was much more straightforward, actually. So when we collected all the information up, Borough Happold they created a digital twin of the village, and they put all this information in with millions of other pieces of data. I think it's something like 3 million pieces of data overall for the project. So whereas I'm not going to talk now about the kind of the overall results of these surveys for the houses, because we were looking at a bigger picture. All this went into to see a view of the village. So the digital twin took the the information available in the public realm, such as EPCs, the data that we did on an anonymous basis, plus all the UK Power Network grid system, and it was all put into to this software, and then we can start to manipulate that software to produce different scenarios, to say, well, what would happen if we just left everything to run as normal? People put in heat pumps as they wanted, and what would that look like for everybody, UK Power Networks, for us? Or what would a coordinated approach look like? We also looked at how many renewables could be fitted in the village. And one of the headlines was 37% of Barkham's annual electricity demand, and this is with heat pumps, could be met by community renewables if we went down that coordinated approach. So we're getting some really exciting figures out of this project. And here's more details. So annual electricity demand existing, now this is without fitting heat pumps, this is with the village mainly on oil, is about 7 million kilowatt hours per year, annual electricity demand. If we went an uncoordinated approach, just kind of left people to do what they wanted to do, the annual electricity demand would be just over 14 million kilowatt hours per year. If we went a coordinated approach, it's 12 million kilowatt hours per year. So that's savings for everybody. The uncoordinated approach means that there's a very light touch on retrofitting to reduce heat load. it means more work for UK Power Networks, which ultimately kind of flips back onto our bills because we kind of all pay for it. So there's some really interesting things coming out. And here's something very specific. This is one of the houses and the results from one of the houses. Happens to be Ollie's house. So you can see that with an oil boiler, and these, unfortunately, these prices are now way out of date because they're a month old. But you can see the comparison. With an oil boiler, it would cost Ollie £1,390 to run. With a heat pump, it would cost £870. If he goes on to a heat pump, his carbon will go down and down as the network decarbonizes. So his carbon will be zero by 2035 on the basis that the electricity network decarbonizes. If he stays on oil, he'll be at 7,207 kilograms of carbon emission. The report flagged up the heat pump rating, which was 7 kilowatts. And he needed some radiators upgrading from his current system in the kitchen, bedroom, bathroom, kitchen and bedrooms 1, 2, and 3, and also to put a radiator in his study. And there was also some insulation upgrades in the kitchen, bathroom, and study. And I also wanted to share a few learnings we had from this process, I would say that really, if you're going to be starting anything that is time critical, so for example, the monitoring had to happen over winter and we didn't start early enough. So really start to plan in the summer for a winter project. And identify your equipment and test that it will work. And this is going to take a lot more time than we thought that it would. Training the installers is really key, and heating in his existing houses is not straightforward. So the monitoring process, was quite difficult, and we needed to. Fortunately, we had technical people on hand, but that's something that you would need to do. And that's it. And hopefully, if I still have power, I'll be available for questions at the end.
Thank you very much, Nikki. I hope people found that interesting and helpful. I think there's been some questions in the chat box that I might encourage you to answer while we move to John Hubbard, who's going to do the first part of our presentation about heat cameras and how they've been using them in Energy Alton. And then we will hand over to Nick Rouse from Avesco, who will give a bit more technical information about heat cameras and also how to understand the images that you see. So John, are you ready to go?
I'm ready to go, yes. Good morning, everybody. My name is John Hubbard from Energy Alton, and I'm going to do the first bit on the thermal imaging, which is, if you like, our story, which probably is fairly typical and could be applied to other volunteer groups. First of all, Energy Alton is a volunteer environmental group. We started in 2010-11, and the focus of the group was on home energy use, home heating, saving money in the home, improving comfort, and as a byproduct, saving CO2, because back then green wasn't a particularly strong label, but saving money and so forth was. So we focused on that. We got a grant from DEC, Department of Energy and Climate Change, which allowed us to purchase a thermal imaging camera. And so that's what we did. This is the camera here. It's a FLIR camera. And it was then quite expensive. This was £5,000 for the camera, and also £2,500 for a wide angle lens, which I'll mention again in a minute. So now these sorts of cameras are much, much cheaper because of technology advance. So I suspect a similar camera would be about between £1,000 and £2,000. Mind you, it's still working fine and doing the job. So we bought the camera. We purchased training for £500 for a number of people. and we started doing thermal imaging. The initial offer was 1 image per house, because our aim was to get a big coverage. So we at this time also we were doing free home energy surveys. We had a high street advice centre and quite a lot of publicity going out about other things like free loft insulation. So we were able to get the message out, and we got quite a lot of people wanting thermal imaging. So we did 1 image per house plus information about how to interpret that. And since that time, I guess we probably, in that initial phase, we did about 300 surveys. The other thing to say about the camera is that it probably is a lot easier to use these days, I have to say. So we don't let it out for other people to pick it up and say, let's have a go, because it's not that simple to get good images. For example, we had to buy a wide angle lens, because if we're standing in a street taking a picture of the outside of somebody's house, the standard lens wouldn't fit. You wouldn't get a whole house image in that picture. So we had to get a wide angle lens at additional cost, but once we got that was fine. We trained up a number of people, and today we tend to do fewer images, but we do more pictures per house, and we tend to treat it as a sort of a mini survey based around the thermal images. So we might do 10 or 12 pictures. We download them. Today, of course, you get Wi-Fi cameras, so you can automatically upload that. With this one, we have to put a cable in and download the images to the laptop, but we can easily then send those on to the homeowner who's got them to play around with and blow up and so forth. What do we use it for? Well, really consistently from the beginning, it was to stimulate discussion and action. We're not professionals. We don't give technical reports. That can be done, but we don't do that. We focus on the fabric problems, if you like, or the fabric challenges in the house. Today, one of the common questions is my cavity wall insulation working or not? So that's not totally easy to work out. It's probably easier with a borehole camera than it is with a thermal imaging camera, but that's a typical question that we've got. And we obviously look at the issues around insulation in the roofs, the extensions, things like garages with rooms over where people feel cold. And as I said, we stimulate action, hopefully, so that people can work out their priorities as to what they want to do. One interesting anecdote to throw in at the end of this is that my colleague did a survey on a 3-year-old house this week and found that there was no insulation between the internal garage and the bathroom that was above it, and there was no insulation in the dormer loft. So that's a 3-year-old house. So it just shows that it's not old houses that have got the problems. So I think at this point, Liz, I will hand over to Nick, because obviously he's got information about other sorts of cameras.
Lovely, thank you, John. And yeah, I'll hand over to you, Nick, now. And he will also show some images and I think analyse or help people understand how to see the images. Just looking for you. You here, Nick?
Yep.
Yep, great.
Yep, right. I'm going to talk mainly about this little gadget, which is one of the cheapest high resolution cameras going, and it works by plugging in to your mobile phone. So it just plugs in the bottom. So if I start my screen share, now, where are we? Right, can people see that? Right. Right, the the actual device is a FLIR device. It's right at the bottom end of their range. FLIR is the major manufacturer in this area, and like the one you saw, many of them go up to thousands of pounds. So it comes in 6 varieties. There is a low resolution trio, which only has 80 by 60 pixels, and the higher ones at 120 by 160 pixels. And it has different connections for the, if you have an iPhone, there is an iOS Lightning connector. And if you have an Android phone, you may either have the micro USB or the Type-C USB. Those are the prices you can see, including VAT, that I got from one seller. They might be available at different prices. At one time, the iPhone one was more expensive, but they now seem to be the same price. One of the features of this device is that, as well as a thermal camera, it also has a visible camera, which you can take as a separate picture if you want. But one of the useful things is that you can extract the edges out of the visible image and superpose them on your thermal image, because quite often the thermal image is quite bland and not much changing across it, and you need to see where it is. So you can see on there the window frame, and you can also notice there's a black spot at the bottom of the window there. That means it's French windows, they open, and you can see that air is leaking through at that point. It can take either a single still frame or a video at a fairly low frame rate, and these are stored on your camera just the way that you get from your normal camera. You can also put a temperature bar on the side to tell you what the various colors correspond to, and you can either let it automatically spread the colors across the temperatures it can see, and it will change as you swing the camera around to look at other things. But if you want to do comparative measurements inside the house, you can lock it into one range. You can also manually change it, and this is useful for external shots, because if you have a bit of the sky, then depending whether you're looking into the sun or out of the sun, the color at the sky dominates the range if you let it run automatically. So it's useful to be able to set it down so that all the colors you can see are spread over the bits you want to see, which is the house. One bizarre bug in the software is that you can't actually record that bar. If you record it, it gives you the vision, the picture without it. To get that picture there, I actually had to take a normal camera shot of my iPhone, my smartphone, to get it. I don't know if they're going to sort it out, but it's been around there for some time, that bug. You can also set up a number of spot points. You can put up to 3 spot points and measure what it is at that point. And this is looking along the corridor just outside where I'm speaking now. And you can see the underfloor heating going along there. And I've got it, the spots poised above one where the pipe is going underneath. It tells you it's 23 degrees. You can also see along the edge there that I haven't filled underneath the skirting board sufficiently, and hot, cold air is leaking in under those, under the skirting board there. Right, set up, there's all sorts of things recorded from ways you record the pictures, and you can set them up. If you've got GPS location on your phone, it can record that. Now you can almost set up the emissivity. Now this is technical. If you don't understand it, just take the advice of setting it to 95% that I come to. But for those that want to know what it's all about, emissivity is a measure of how much infrared is emitted from a surface at a given temperature, and it varies depending what the materials is. Now, there's a theoretical maximum value, and the emissivity is expressed as a percentage of that maximum. And we can set it up on the setups on the device to match the expected value. And that value is then used to calculate the temperature that it says that surface is at. Now, most matte surfaces in a house will have a very high emissivity, so it's normal to set the emissivity to 95% of maximum. And this gives fairly few errors apart from shiny materials, such as copper pipe for the plumbing and glass windows. And if you want an accurate measurement of these materials, if you stick a paper label, especially one if you've printed it black all over to the surface, and measure the paper temperature, then it will give a much more accurate figure than looking directly at the glass or the copper. The glass has another problem with it, is that it reflects, and sometimes you're measuring your own reflection. You can often see on the picture your outline set against the glass. So if you want to, say, measure accurately just the glass itself, put a bit of paper over it and stick it down on the thing. It's fairly easy to set up. The device has its own battery, and this needs charging up before use. There's cables supplied, and you can use any normal, if you've got a desktop with the USBs are giving out power, you can use those, or any charging device that uses them. But you've got to have a USB Type-C connector on the end of that, because the charging plug is USB Type-C, no matter what the data output of the mobile phone of the device is for connecting to your mobile phone. There's an application that you can download from Play Store or a load of other places, and you load that down, install it. They don't give you a manual, so you can download one. And the plug at the top of the FEAR device plugs into the corresponding socket on your phone, and there's a roller that moves that plug in and out. So if you have a thick protective cover, it can still reach in to do it. Once you've got that, you switch the device on with the on-off button on the moment, open your application, and after minutes or so, if it all goes right, you should be able to take your pictures. I looked on the customer reviews and has several hundred reviews, and they are split between those that give it very high rating because they think it does marvelous things for the price, and those who have a low rating because of a battery problem. And these include the lifetime of the battery once it's charged being very small, sort of 10 minutes or so in some places, and sometimes them totally failing. And unfortunately, the battery is not replaceable. If it fails and you haven't got it in warranty, you've got nothing to do but throw it away. So that's £300 or £400 down the drain. And there are reports that the FLIR have been slow to react to these. And the camera I've actually got, it came about because of that a year or two ago. Someone had one that had failed and they were going to get another one, but they really wanted a iPhone 1. So we swapped over, but in the end, FLIR didn't replace it and the fellow had to buy me one. So we finished up each buying one. There are a number of other ones that work on the same principle of going into this mobile phone. Seek is the one that most people were complaining on the Amazon site were saying you should try, and said it doesn't have a video camera, so you only have the infrared. But there are other ones there that I show that they're doing. There's one point about these is that they all rely on the connector to hold the thing together. And it looks to be a little fragile if you're breaking it. So I don't know whether a community group buying one of these and letting people use it unsupervised is all that good an idea. You'll have to take your own judgment as whether they're likely to get broken by anyone that uses them. So that's about it. Thank you.
Thank you very much, Nick. Right, before we go into the questions, I would just like to say thank you so much to all the speakers. It's been a very full lot of information, and it's made us, well, two things that I'd like to raise. First of all, one of the wonderful things about community energy is that we give so freely to each other of our experience and our learnings. And it occurred to us as we were sitting listening to the presentations that we'd love to know what all the community groups present are doing. So do please, if you're doing some energy saving work in any way, do please let us know in the chat what projects you're doing, because we can then all, you know, it might be useful for people to network and exchange with each other. So please feel free to put in the chat what your community energy group is doing. The other thing that just occurred to me, and I was trying to set up a poll, but I didn't have time to do it, is I was wondering whether there's a lot of questions and we've got half an hour. So I was just wondering if we should have breakout rooms so we could have questions about the energy surveys in one room and questions about the heat camera in the other. I think what I'll do is I'll ask you all to unmute yourselves. No, I'll tell you what, if you can raise your hand if you would like breakout rooms, that would be helpful. And then I can figure out whether to do breakout rooms or just have questions and answers all in one go. So I've got 1, 2, 3, 4, 5, 6. It's quite a thing doing this on the hoof. It looks like no breakout rooms are probably preferable to breakout rooms. So we won't do breakout rooms for questions this time round. Sorry, guys. Let's start on some of the questions. Could the speakers unmute themselves? And I think the first question was from Malcolm Kenwood. So Malcolm, would you like to unmute yourself? And then Holly Whitelaw, you get ready to unmute yourself. I can see you've unmuted yourself, Malcolm, but I can't hear your question.
My question, I'm trying to remember what the question was.
About software.
It was just a question of, he mentioned software, but it wasn't, it just looks like a useful bit of software. And I just want to know a bit more about the software, where it comes from. Can you get it for free? Does it cost money? What? Just a bit about the software.
Is that a question to me, Malcolm? Was that on?
It was.
Was it my software?
It was to do with the.
It was a question for Michael, and along the same lines, actually, Linda Burnham had a question about accreditation and retrofit work. So, Linda, do you want to add your question to that, and then Nikki or Michael, you could answer?
I think it's probably a question to Michael if it's about his software.
Yeah.
Are you talking about the whole house plan?
Yeah, he was.
Yes, that is applicable. The software there is provided, or not provided, but it's used through Retrofit Works organisation. So it's their own software that they've generated. But it can be used. Normally, we were doing some bits and pieces under the Warmer Sussex, where a cost of a thing was about £250 to provide the initial whole house plan through a survey, and then a follow-up call, generally half an hour, but generally they would normally go on for about an hour to an hour and a half, depending on the client's sort of discussions. But it's not something you can buy off the shelf or add to. It is more created, which belongs to Retrofit Works as its own product.
I was trying to think of if we're community energy groups, and we're trying to help people, then we need to think how we do that and the tools we need to do it.
Yeah,
and that's
with the whole house plans under the local authority distribution scheme, you've got there's two criterias in the sense if you've got a family household, total earnings can't be more than 30,000. They get all this as part of that. It's all included within the whole within the LAD local authority distribution scheme. It becomes and forms part of the PAS 2035. So there's a whole process that will follow through, because they can get grant funding up to approximately about £10,000 presently. But under LAD 3, as I said earlier, it's getting weighted. If you're more rural, it's going to cost you more to put in an air source heat pump in than the 10,000. So it gets weighted that way. Typically, though it's due to start at the end of March, we still haven't got all the 9 major details from the government or the local council to sort of say this is how much it's going to be. So we're still waiting on that clarification, but generally at the moment it's 10,000. If a landlord could also apply to the scheme, but currently could only get a grant allowance of £5,000 towards measures. Anything above that, they would have to pay themselves. So they have to pay 2/3, and the maximum they would get would be 5,000. So effectively, if the works were 7,500, they could apply. They would pay 2,500, the landlord, and the council would pay 5,000. If the project costs were more, say they were 10,000, the council, the landlord would then have to pay the 5,000 difference himself, but still get the £5,000 maximum allowance.
It's perhaps worth saying that from the new scheme at the end of March, LAD 3, the scheme is split into 2. LAD will only deal with those that have mains gas, whereas HUG
is the ones that deal with the outside.
To do with those that are off it, and they have higher limits to the grants for those people.
Liz?
Thank you. Yes, John.
Can I just make a point? I mean, clearly, the local authority schemes where they're focusing on fuel poor homes, those who are necessarily on benefits, etc., have got the capacity to go through the schemes and get, if you like, professional reports from people like Michael and others. If you're a community group looking to do home energy surveys on anybody's home where there's no particular grants around, you don't need software. You can do a home energy survey. We tend to just give an email report, because it's all about starting the conversation and focusing on priorities. Obviously, homeowners can then look at more technical ways to get the details that they want, and producing the equivalent of an EPC-based report with more information. But it's still possible with some training to be able to start that conversation with homes and focus on issues that then the homeowners take on themselves. You're muted, Liz.
I know, I lost myself to unmute myself. Now, Sylvia Watt had 2 or 3 questions. So Sylvia, would you like to ask your questions? And Stuart Bird also had a number of questions. So I'd like to suggest Sylvia asks her question, then Stuart, then Kirsty, who had a question about PV and electricity bills.
Thanks. I didn't really have any questions. They were more comments on what the presentations. I mean, if I could just say quickly, I thought Nick's presentation for our purposes was extremely helpful. We've just bought an energy camera. We're going around the village doing heat loss surveys for free. And there's the camera. Can you see that?
Yeah.
She's written the box where she's from.
And cost £370. And we're using it as a way of giving people advice from an amateur perspective, we're not getting into any detail, but these tend to be people who are going to do an extension, want to know about their insulation, and that's working very well. It's also allowing us to bring the community to think about what they can do for themselves to reduce costs and save energy, and at the same time save the planet.
While you're going round, look up. That's one of the common problems. People insulate their roof.
The attic.
The attic.
The attic.
Yeah.
We do that.
We do that.
2-page checklist.
Yeah, but the trap is
Yes,
rarely insulated. It's a particular problem if you have a ladder, because you have to try and somehow get the ladder round the insulation. But
yes,
there's quite a lot of people have masses of fibre wool or rock wool over their loft.
Yeah, forget the loft.
But don't bother about the hatch. And you can see it standing out there. Enormous losses through that.
Yeah.
We have a 2-page checklist, and it includes the loft hatch too. So thank you.
Yeah.
Happy to talk about Great Green Bedouin, which is a wider project trying to, we've sent out a survey, had 450 responses. It's to try and focus the community on doing some community level things that is supported by a large number of people. And one of the top ones is community energy. Thank you.
Thank you, Sylvia. So I think I said the next person was Stuart, and then Kirsty.
Right, sorry, I just had to make a note of all the questions I'd asked. Yeah, well, the first one was a reference to PAS 2035, which I think, Michael, you just mentioned in your last bit there, which is that the standard that you were adhering to, or is that what?
Yeah, because as of now, any government funding has to go through the PAS 2035. So I'm a retrofit coordinator, retrofit assessor, so I can do the process all the way through. But effectively, yes, we're doing a lot of that now with door installation and things like that. The only thing really that doesn't come under PAS 2035 is solar panels. That comes under the MCS certification, and because it doesn't have any interface with any other areas, it can be deemed not to have to comply with PAS 2035, because the MCS certification deals with all of that side of things separately. So that's where it is at the moment with solar panels. But everything else that gets supplied to the property, whether it's under floor insulation, things like that, there is a whole there's 14 different documents that we have to produce through thermal bridging, fire risk, inherent risks, pathways to follow, whether that's A for a standard house, B for a traditional, or we would then start going into the more complex ones that are solid brick, pre-1920, listed, conservation areas. There's a lot more documentation required.
Is it potential, just a thought for everyone, that PAS 2035, when it becomes more widely understood as the sort of the standard for anyone to retrofit their house to, that training up as a coordinator or an assessor under that scheme might be something that Community Energy would do for some of its personnel? Well,
I certainly think it's going to be the way forward with the PAS 2035 now in fully effect. That it would be beneficial to each community to have at least one retrofit coordinator. You don't necessarily need to have the retrofit assessor, because the coordinator is almost becoming like building control officer and inspector. What we have identified some of the key issues under the PAS 2035. It was designed to look at the whole house approach. And that whole house approach is great, but if you've only got one measure, so for example, where we're dealing with now, you've got an old lady that's worried about her drafty doors and she wants to get them replaced. She's also able to have some solar panels to help with her energy requirements. But under the PAS 2035, ventilation kicks in quite heavily throughout the whole process. So as part of the replacement of the door, the considerations have got to be taken that are there in all wet areas, including like utility rooms, etc., have to have mechanical ventilation. You then have to have trickle vents on windows that don't have any things there. You also have to have door cuts underneath each individual door of about 8 to 10 mil. Now, this is just because of one measure. Now, as a whole, when you're doing the whole house, it would be different. But because of this one measure, all of a sudden from replacing that drafty door front and back at £1,600 a door, you've now then got £3,000 or £4,000 worth of work to comply with the ventilation of it. So this job, in fact, then the electrician comes along and says, okay, fine, I'm coming to install these dehumidified, consistent mechanical ventilation, but your wiring's out of date. So that you need to upgrade the fuse board to the 18th edition. So all of a sudden, the £1,600 is £8,000 or £9,000 under there. And there's a big thing within the industry dealing with bays and that to address these things. At the moment, it's all about to get away from it. You know, you're telling ladies that for your drafty bit, we're now punching holes in your wall. We're punching holes in your windows to put trickle vents in and things there. So there is a lot of confusion within the industry that they're talking about minor measures now that you would have points. So 3 minors would make a major, but I don't want to go too much into it now, but there is, the system is geared for whole house, somebody buying a property, ripping it apart or doing some extension works and doing some 3 or 4 different measures and maybe more over time.
Okay, thank you.
Thank you. Kirsty, did you have some questions? And then Alistair Mackenzie.
Yeah, I had, I mean, I may have missed something on the retrofit works plan that Mike put up, but it looked like the energy bills didn't go down when somebody put solar PV on. Did I misread that, Mike? I didn't quite understand. Well, it's
the thing being is it's recognizing it doesn't take into account the reduction or the property's use at this present time. That's something that can be evaluated through the installer. And the installer at survey could say, right, because of the orientation, purpose, you know, the size of panels you've got on the roof, the efficiency of the panels, it's too much information to put at this stage. It's really done more at survey, of which then once we've got that, we can then put in specifics, and that will then the modelling of the savings would be far more consistent and correct to that. But at this stage, you don't know if they're going to go ahead with all of that, so it's too much work to do. It's only a guideline, and effectively the solar panels aren't actually accounted within the energy efficiencies, though there's a pricing structures there. It's not really counted in terms of cost and savings until at some point before say install, the installer can come back and say, these are the panels, this is its orientation, this will give you 3,800 kilowatts per year, or it will give you 2,500 kilowatts per year based on the number of panels we've got. Because it could be, you might have 2 systems, one sort of southwest facing, one south.
Yeah. No, I understand all of that, but so basically though, you have to ring fence your report to the consumer with a lot of caveats which say, don't read too much into this, don't read too much into that, don't read too much into the other.
Yeah, I mean, again, it's about pricing. How much do these things cost? Again, it's all up in, I mean, it's just mad to try and cost something now because of Brexit, secondly COVID, now World War III, now the war in Europe. There's nothing you could actually say, well, this is what it's going to cost now. It's only really gleamed once. You don't have to, you can find out specifically when you know what the cost of the actual install of the product's going to be. Because at the moment, it's just giving you an overview. It gives you a ballpark figure. You're not measuring up to say, right, if you put the system in, this is what it would actually physically cost you. You can give an indication, but all those figures are really being thrown out the wall, and there's no real guidance on it.
There's a problem with trying to work out the financial benefits of PV systems, because you have to work out how much will be used by the user and therefore displace expensive bought-in electricity, and how much goes out as exports, getting only the smart export guarantee of about 5.5p. So it's relatively easy to work out how much electricity will be generated. There are a number of free programs around. There's one by the Canadian government that is fairly accurate, and it works all over the world. You put in your latitude and longitude. There are more sophisticated ones like the ones I use, but they are expensive. But you can work out how much you want. You need half-hour data. Now, if you've got a smartphone, a smart meter, and you have opted to have it read every half hour, and you can get onto your energy supplier, they will tell you your half-hour figure. But most people don't have it, and you need some fairly sophisticated software once you've got it to work out how much you will save in terms of money. As I say, you can work out how much you will generate, but savings is more difficult.
Thank you. Yeah, no, I'm quite familiar with the workings of solar PV and the payback and everything. I think the point I was making was, why is it in there in that format when it's going to be quite meaningless as a kind of tool for the user? But you know, that's fine. Mike's sort of explained it. My second question, if you don't mind, was about the whether there's an absolute optimal figure, like a passive house number for the temperature of the external surface of a wall versus the ambient or atmospheric temperature, so that whether there's that's more of a difference that you could measure where it doesn't matter what the internal temperature is. Is there anything that?
Yes, there is. The thing you want to do is the degree day measurements, and these are available all over the country. And they will tell you how many degrees below the reference temperature, which is normally something like 19 or 17 degrees, it is. So you can total up the amount of heat that will flow through. So once you've got your U value, overall U value for the house, you can work out how much heat will leak out through the year by applying the degree day measurement. And I say these are available online all over the country.
No, I was really meaning, if I'm taking a photo of a house from the outside, what should be, and assuming it's cloudy, there's no sunshine, no sun radiation on the wall, what would flag to a homeowner that their walls are leaky as a differential from the atmospheric temperature on the day?
Well, if you measure the temperature inside and outside, and you know the U value, you calculate the U value of the wall, you can tell how much is leaking out.
Okay, thank you. Thanks very much.
John Hubbard, are you able to add anything to that question, to the answer to that question?
Well, I don't actually know the answer to the question, but all I know is that the key issue is the difference between the internal and the outside, as Nick says, the outside temperature, and you're looking for that. So I don't think you can sort of do a spot temperature test on a wall to say, well, that's above or below what it should be. But it's raised the question in my mind, so I will no doubt go away and find out.
Thank you. Okay, next is Alistair Mackenzie, but just as you unmute yourself, John Laker, you've had your hand raised for ages. Do you have a question? And if so, do speak after Alistair.
Okay. Good morning, everyone. I'm a member of the Hambleton Greening Campaign, and we recently bought a FLIR camera. It's the cheapest one, which is about £220. And I would say initially it was a nightmare getting it to connect to the mobile phone, the actual software. And and involved me buying a new mobile phone to get it to work. There was also an earlier question about the temperature scale. I actually downloaded the FLIR software to my laptop, and that generates a really nice report with all the details that you would need. But to get to my question, and it's partly been answered in the previous discussion, my thought was, if I take a spot temperature of a window outside and it's 15 degrees centigrade on the window, if the temperature of the room is 16, then obviously the thermal insulation is dreadful. Whereas if the internal temperature is 100, then it's brilliant. So I assume that as well as taking an outside photograph, you also need to record the temperature of the room at the same time as you're taking the temperature outside. I just wondered what other people's experience was.
Yes, you do need to, if you're trying to work out how much is leaking through, you want to work backwards to the U value of your window. You need the temperatures inside and outside. And as I said, if you're doing it with an infrared camera, you need to stick a bit of paper on it, because the emissivity of the glass is very variable, depending whether you have self-cleaning coatings on it and various other points. But if you stick a piece of paper on it and then measure it, you get a fairly accurate thing. But a piece of black paper will have emissivity well up into the high 90%, so you can take the reading as fairly accurate.
Our rule of thumb is that we need a temperature difference of 10 degrees between the inside and the outside to make a meaningful measurement using a thermal imaging camera. So in effect, we tend to do our thermal imaging outside from October through to March. We can use the camera inside to get differences, but it is not so effective to use that after March, because the temperature difference reduces. I don't know if Nick has got the same view on that.
It is, but you can, if you're looking for the weak spots, such as looking up at the loft trap, that really shouts at you. If you're trying to work the fine figures, then indeed you do need to know it. And likewise, the leakage I can see under the skirting board is showing up, and a lot of people don't realise, especially on older houses, how much draft leaks up under the skirting board and in.
Thank you, Nick. John, you have a question, I think, and then I think Richard Caro has a question.
Yes, it's more some information than anything else. I'm from Marlow Energy Group. We recently bought a FLIR C5 infrared camera. It's fairly complicated, but we managed to load all the stuff onto the computer, all the records that we've made, and subsequently everything onto the cloud through FLIR's programs. I would say that our surveys have been external due to COVID so far. We write an interpretation report, and as the other gentleman says, we're doing it October to March, so we haven't got much time left this winter. We do require that everybody has their heating on, so you've got the differential, as someone else mentioned. We have found with this particular camera that it works remarkably well at dawn and dusk, but not at night, which is a big frustration. Very blurred images indeed. If anybody's got any advice with regard to the FLIR C5 and how to use it at night, be greatly appreciated.
Well, it's one of the cases I said where you need to manually adjust the temperature scale, because if you've got a vision of the cold night air and leave it on automatic, then it will put the scale up so that the cold air is part of the scale. So you want to get in on the manual adjustment thing and raise the bottom end so that it doesn't show you the cold air in the scale?
We have done that and we've not had any luck, and then we've taken photographs which avoid the sky totally, like a picture of the patio doors, and still that's incredibly blurred.
I'm just going to interrupt for a moment because we're rapidly coming to the end and there are a couple more questions. Can I suggest that perhaps John and Nick stay on afterwards and have that discussion if you have the time available, both of you?
Yeah, can do.
Okay, thank you. So Richard, you had a question.
Sorry, was that me? Thank you. So we've got our new FLIR One camera, and it's been bought by the parish council. The plan is that we will loan it out to residents in the parish. What I would be keen to know is whether people have got experience of that and whether they've drawn up guidance, not just on usage for such equipment, but also privacy issues. For example, what they can and cannot take pictures of. What we don't want is people going around taking pictures of other people's houses necessarily, because there might be a privacy issue there. And therefore, when anybody has any experience of that, it would be good to know.
Yeah, I think that's a really good question. I invite John Hubbard to answer, and if anyone else has observations or experience, do please put it in the chat, because I think it would be great to get a kind of guidance document.
Yeah, basically we haven't lent out our camera, partly because for the reasons that Nick said earlier about the technical side of emissivity, setting your temperature ranges, and so the work of training other people to go and take it over to do it in their own house was more work than actually going to do the image ourselves. So I think the idea of lending cameras out has a disadvantage, because then people are using information that may not be accurate, but based upon the loan of your camera. So I don't have any other experience of other groups. Just one quick point to make, and that is that in a village close to Alton called Beach, what they've done there is to, using a grant from the parish council plus a fee per household of, I think, about £35, they've done professionally produced thermal images of 65 homes, so that and each of those homes gets a full report based upon the thermal images taken. That's an alternative to getting your own camera and doing it as a group. Clearly, they are professionally produced reports, and no doubt can be very effective. And maybe once the scheme has been trialed more, other homes will take up the offer. So I think that's just a mention of another way of doing it than owning your own camera.
Yeah, I would just add that you did say it was a FLIR One, didn't you? They do look remarkably fragile on that when the whole thing is just hanging on the connector. I would be very loath to let it out in public if it is one of these little FLIR Ones. Yeah.
Yes, it was.
That is all that's holding it together. And if someone drops it or bends it, it's only too easy to break, and it's not replaceable.
Thank you. Peter England, I think, well, Peter England and then Holly Whitelaw, if she's still here, and then we're going to have to close it because we're going over time. So I'll just, Peter, do you still have your question, or has it been answered? And the same for Holly Whitelaw.
Some of my questions have been answered. Sorry, I've done many, but what I'm interested in is what cameras people would really recommend to buy now. There seems to be issues with the lower end and the connections. If you were to spend about £1,000, £2,000, what's the recommendation? And how do we get a grant from? I can't see us getting a grant from Surrey, but I can try. I think someone mentioned DEC. How you get the grant from DEC. So they're the two questions, really.
Well, the C5 that someone mentioned is about 550 or thereabouts, and I think is a fairly robust sort of thing. You don't actually need very high resolution. You're not if you were using a thermal camera for you looking at a switchboard and you want to be able to see every single wire and switch, then you do need high resolution. You also need absolute accuracy. But to some extent, it's largely comparative measurements that you're taking, and therefore you're not after a degree or two absolute accuracy. So C5 seems quite good for. It's what Avesco have bought. This one is my own personal one, this little FLIR 1. But Avesco bought a FLIR C5. I think it's probably good enough for most household surveys, which has got all manner of unknowns in all manner of departments. It's not like you're doing a very careful absolute measurement on it.
Okay. Thank you.
So Holly?
Hi, greetings from Cornwall. I'm a spy from the southwest. you guys rock, and I've been so inspired. I've had most of my questions answered. I'm really interested to know whether Borough Happold are linked with funding that helped community groups, because what you've done there in Sussex is fantastic, and proving how much you can save in a community joined up thing, Nikki, is just the way forward. So thank you. We can now follow in your footstreams, hopefully. So do you know if there's if they support community groups, or we have to find our own funding, and how much did it cost you?
So we receive funding through UK Power Networks through their NIA funding stream, which comes from Ofgem. So Ofgem give kind of large pots of money for much larger projects, and then allow the DNOs a smaller pot for smaller innovation projects. So basically we worked with the innovation department at UK Power Networks, and one of our partners was Borough Happold, who did the engineering side. So the project was almost £1 million overall. But not all for us. But larger projects can be multi-million-pound projects, and they always look to see how this project can be scaled, across the region. So it will be one innovation project to be scaled, and we're looking to write the book for other communities to see how they can do it, but obviously on a much cheaper scale, from the learnings that we took from the Community Heat project.
I'd like to do it in our parish, because we're all mainly off, well, we're all off gas, and we're really poor, and so it'd be amazing to I'll get in touch with them. Thank you very much, and thanks everyone for your time.
Do get in touch with me, and then we can kind of point you in the right direction, rather than with Borough Happold. But yes, if you're off gas, the price of oil today is almost £1.50 a litre.
But electricity is also really expensive.
Yeah, it is, yeah. But that's when community ownership and local generation can really start to bring the price down, and also provide a little bit more resilience to the whole grid, by doing that. I'll put my email address again in the chat for you, Holly.
Thank you, and all the best to everyone.
Thank you.
There was one other question, which was, are there exemplar counties that we can utilise to go, oh, come on, Cornwall Council, these guys are doing this? Is there a one-stop shop for community energy?
Perhaps Ollie can answer that.
Ollie, are there councils that can be held up as exemplars for other groups to say, look what they're doing, why can't our council be doing this?
Well, it's a really good, next week, Community Energy England and Community Energy South on the 15th are running an event for local authorities who are doing best practice to demonstrate that to other local authorities. And
So we're working on it basically. But I did put a note in earlier. I think I see in East Hants, I made a point that most local authorities now have climate officers. Those have been in post really from last April or some longer. So do get in contact with them because they do have budgets for things like this. And because so many of you cover so many different district authorities, I think it would be a really good thing for at least you to make contact with your climate officers and showcase what you're doing and ask them. For example, I know East Hants contacted us and said, we're looking at buying thermal imaging cameras. And last week, Bournemouth contacted us as well and said that they're starting to provide them to parish councils. So I hope that answers the question, but do contact your climate officers.
Thank you.
Posted.
And I have one other thing to add to that, which is next week we're doing our masterclass on local area energy plans. So that might also be worth engaging with. I'm very conscious that we've gone over time, so and lots of people have left, obviously. But I just want to, if our speakers need to leave, do please feel free to leave. And thank you so much for your time. But I'm also conscious that there are a couple more questions. So if you need to leave as a speaker, yeah, exactly. The local area energy plan will include Borough Happold. If the speakers need to leave, please go. But I noticed Alistair Mackenzie had a question, and Peter England, if he's still here, had a question. But of course, I quite understand if you've got to go.
I was just going to comment again on the FLIR cameras, that I spent weeks reading all sorts of reports and reviews on the FLIR cameras and bought the cheapest one. And apart from initial problems with the software, it seems to work perfectly fine for what we need it to do. So, and that was £220.
Yeah, I got one of the, yeah, as you see, one of these, and it's behaved to me. But if you look at the reviews in Amazon, the customer reviews, there are at least 100 people have written in saying that their battery has died on them.
Right.
Now, there's not many very recent ones, so perhaps they've sorted the problem out. But around 2018, 2019, there was lots of people. Some arrived dead. Some, the charging lasted only 5 minutes before they had to recharge it. And some, they just died later. So there certainly was a battery problem. And I say, indirectly, mine came because of someone else had a battery problem and were having trouble getting it. Sorry about my familiar spirit here.
Okay, that was it.
Are we all done? I think we may be done. In which case, I just want to again thank our speakers, and particularly for spending so much time here, and just thank you all for participating. And come again next week. And if you're not signed up, oh no, we have one more question. John Belton. I thought we had a question from John Belton. Maybe he was raising his arm for some other reason. So again,
perhaps he was saying goodbye, waving.
Yeah,
goodbye.
Perhaps he was waving goodbye. It just looked like he was waving his hand.
There's just a question about downloading the chat. I'm not quite sure if everybody's clear and happy about how to get hold of the chat afterwards.
Well, also, to be honest, because there's been lots of discussion about downloading the chat, Jessie is going to save it and send it out to everyone.
Right. Okay.
Hey. But please provide us with your email addresses if you need it.
Well, they should be signed. We have their email addresses through Eventbrite. So thank you again.
Okay. Thank you very much.
Bye, everybody. Peace and love.
All the best.
John Hubbard, you're my hero.